Hi, good morning, good morning, good morning. Hi, good morning, good morning, good morning. No one is saying anything. Good morning, good morning, good morning. Hi, good morning, good morning, good morning, good morning. Yeah. Good morning, Farida. Good morning, good morning, good morning. Sajid, good morning, good morning. Yeah, good morning, good morning, good morning, good morning. Yeah, Kavita, good morning. Sanjana, good morning. Srinivasa Reddy, good morning, good morning, good morning. Bagunara, everyone Manchi at home? Yeah, I'm also good, Sajid. Yeah. Bagunara, everyone Manchi at home? Naved, good morning. Everyone Manchi at home? Everyone Manchi at home? Very good, very good, very good, very good. So what's going on at home? Yeah, directly proportional. If students are Manchi, teacher will be also Manchi, directly proportional. Yeah. So क्या हो रहा है घर पे? What's going on at home? क्या हो रहा है? Chilling or studying? What's going on at home? Chilling or studying? जल्दी जल्दी बता दो भाई. We'll start with the class. So what's going on at home? Chilling or studying? What's going on? No one is saying anything. Yeah, chilling with studying. Kusma is saying correct. We are not normal people, sir. We are ultra pro legend. We have a target that next year we have to become doctor. So that's why we are also chilling, sir. We are also doing chilling only, but we are not chilling by other ways. We are chilling with studying. For us, study is not any type of burden. For us, study is also type of chilling. At least for coming 10 months, study is a type of chilling. So we are chilling with studying. Yeah. Huh. They are available once again. I will check today. Yeah. Okay. No problem. It is available in the campus. No problem. But still I will check. No problem. So shall we start with the class? Shuru kare? Shall we start with the class? Shall we start with the class? Yeah, very good. I think in last class we started with graph and I was telling you different types of slope, constant positive, constant negative, zero slope, increasing slope, decreasing slope. These are the things that we study different type of okay, no problem, Gyaneshwari, I will see, no problem. Yeah. And then I think I was also talking about different type of displacement time graph, position time graph. These are the things that we studied in the last class. These are the things that we studied in the last class. Definitely, I will tell you. Yeah, okay, no problem. Huh? These are the things that we studied in the last class. Arre bolo bhai. Increasing slope, decreasing slope. I think Pamu was helping you. Snake theory we studied in the last class. Okay, no problem. Different type of displacement time graph we studied. Yeah, snake also, sir. Okay, no problem, no problem. Yeah. So these things we did in the last class, and we have seen different type of displacement time graph. Today we will talk about velocity time graph. You can write velocity time graph. Different velocity time graph we will talk now. Yeah, what are the different types of velocity time graph? How to get information from that velocity time graph? Our target will be to talk about velocity time graph. Iroju velocity time graph modalendi. We will start with velocity time graph today. Yeah, okay, no problem. Different velocity time graph we will talk. So velocity time graph. Velocity time graph. Acha, what is slope of velocity time graph? Because slope will help us to get everything. What is slope of velocity time graph? What is slope of velocity time graph? Come on, tell me what is slope of velocity time graph? Jaldi. Acceleration. Acha, if acceleration is zero, then which type of motion we will get? If acceleration is zero, then which type of motion we will get? Slope of velocity time graph, acceleration. If acceleration, yeah, then v will be constant. That is known as uniform motion. That is known as uniform motion. Okay, no problem. Acha, if velocity is increasing, then it is. If velocity is increasing, then it is. If velocity is increasing, then it is. If velocity is increasing, acceleration is positive, then accelerated motion. If velocity is decreasing, then it is retarded motion. That is retarded motion. No problem, no problem, no problem. So from here only we will start. Now be focused. See here how we'll be talking. Once you understand displacement time graph, same concept you have to use for velocity time graph also. But their slope was, in displacement time graph, slope was velocity. In velocity time graph, slope will be acceleration. Remaining concept, remaining graphs will be same. So just see here, yeah. First velocity time graph that we will get will be like this. For example, someone gave me velocity time graph. Someone says a particle is in motion and its velocity time graph is represented like this. Can you tell me about acceleration of the body? Can you tell me about acceleration of the body here? I will simply say, sir, you want acceleration. Yeah, acceleration will be 0. This velocity is constant. This is known as uniform motion. This is the diagram for uniform motion for velocity time graph. If you remember, for displacement time graph, uniform motion was like this. But for velocity time graph, uniform. I will simply say, sir, you have given me velocity time graph. I know, sir, slope represent acceleration. So acceleration will be equal to, sir, slope of velocity time graph. Slope of velocity time graph. And you know, in this situation, slope of the graph is 0. If slope is 0, that means acceleration is 0. If acceleration is 0, velocity is constant. And you can see in the diagram also, every time, for example, this velocity, if I mark as 2 meter per second, all the instant body has same velocity of 2 meter per second. That means acceleration, that means velocity of the body is constant. Velocity constant, acceleration 0. If acceleration is 0, this motion is known as uniform motion. Tomorrow they will give you different type of velocity time graph and they will ask you which velocity time graph represent uniform motion. That is this graph. You can check by two ways. One way, sir, everywhere velocity is same. Velocity is constant. Velocity constant, acceleration 0. Or you can use the concept of slope also. Sir, here slope also we can use, sir, because I know, sir, here slope is 0. That means acceleration is 0. And if acceleration is 0, velocity has to be constant. So that's why this is uniform motion. Is it okay? Sabko samajh mein aaya? This is the velocity time graph for uniform motion. We studied displacement time graph for uniform motion. This is now velocity time graph for uniform motion. No problem, no problem, no problem. Second situation. From here only I will talk. Can you tell me if anyone give you velocity time graph like this? Can you tell me about acceleration? Can you tell me about acceleration? Acceleration positive or negative? Acceleration positive, because slope constant, positive slope. That means acceleration will be constant and that acceleration will be positive also. That acceleration will be positive also. So that I will simply say, sir, you want about acceleration now. You want already velocity time graph given. So now what is left? Left is acceleration. Sir, you want me to talk about acceleration now? I know, sir. Acceleration is slope of velocity time graph. And if you remember, this is what I told you, Snake Uncle told you, this is constant positive slope. If this is constant positive slope, that means this acceleration is constant. And that constant acceleration is positive. That means this is an example of, the example of this graph is for accelerated motion. They will give you graph and they will ask you which situation represent accelerated motion. So this is the accelerated motion. And that is what you are seeing in that graph diagram also. Velocity is slowly increasing. Velocity is slowly increasing. So definitely it is accelerated motion. Done. Bolo. And since acceleration is constant for this graph now, so for this graph also you can use equation of motion. Sometimes they give 4 graph and they ask for which graph we can apply equation of motion. This is the graph. Our acceleration is constant na baba. I told you whenever acceleration is constant, we can always apply equation of motion. For this graph, we can apply equation of motion. Is it okay? Bolo bolo. Once you understand displacement time graph, everything is related from there only. So it becomes easy. Nothing to worry. No problem, no problem, no problem. Third graph. Now third graph completely I will give you chance to tell. Take your time and tell me what is in this graph. Tell me about acceleration now. Tell me about acceleration in this graph. Acceleration. Acceleration, don't only say negative. Negative can be variable na baba. Negative can be constant na. So you have to tell me constant negative. That is the correct answer. I will simply say, sir, acceleration means slope of velocity time graph. Acceleration means slope of velocity time graph. And in last class only we studied. Whenever graph is like this is our constant negative slope. So here acceleration will be constant. And if acceleration is constant, that constant acceleration will be also negative. So this is the graph for retarded motion. This is, you already know, if acceleration is negative, that is known as retarded motion. This is our retarded motion. And that is what you are finding in the graph also. Because your velocity is decreasing with time. As the time is passing, velocity is becoming less. So that's why it is retarded motion, and that's why we are saying, sir, acceleration is negative. And for this graph also you can use equation of motion, because again acceleration is constant. So constant acceleration, whether positive or negative, doesn't matter. Once acceleration is constant, we can apply equation of motion. For this graph, for this motion also, we can apply our equation of motion. Now fourth and fifth also you can say. Fourth and fifth are not important here, but okay, no problem. Yeah, you tell me what is happening in this case. Bolo. What about acceleration here? Is acceleration is still constant? Is acceleration is, yeah, now acceleration is increasing, slope increasing. Now I will simply say, you want me about acceleration na sir? Acceleration is slope of velocity time graph. And here we know, sir, whenever we have graph like this is an increasing slope, that means I will say acceleration is increasing. This is an increasing acceleration. Yeah, this increasing acceleration, and definitely angle is less than 90 degree. So that means we can say this acceleration is positive. Means point is acceleration is not constant. Not constant means you cannot apply. Equation of motion will not be now applicable. We cannot apply. Can't apply EOM, equation of motion. No problem. Yeah. So we have increasing acceleration. This graph is not that much important now. Yeah. Now fifth one also we will do. No problem. Fifth one also you have full idea how to talk about fifth one. Fifth velocity time graph is like this. चलो एक बार बता दो. Tell me about acceleration. Already you know acceleration is slope of velocity time graph. So बताओ about acceleration. What is happening to acceleration? Now acceleration is decreasing. Decreasing acceleration. So acceleration is decreasing. And since angle will be less than 90, so you can say this acceleration is positive. That means again I can say acceleration is not constant. And when acceleration is not constant, we can't apply EOM, equation of motion. Is it okay? So these are the different types of velocity time graph that we have. I am giving you time of 5 seconds. See all these velocity time graph. Then we will talk about some questions from here. Yeah. Fifth graph. What is negative? Acceleration, Baba, it is positive. Decreasing doesn't means negative. If I have 100 from 190, from 90 to 80, 80 to 70, 70 to 60, all these are positive only, Baba. Where is negative? Arey Baba, angle will come positive na Baba, angle will come less than 90 na. When you draw the tangent, angle will come less than 90 na. So this is acceleration is decreasing, but that decreasing doesn't mean it is negative. Are you getting my point? Increasing doesn't mean it is always positive. Decreasing doesn't mean it is always negative. Increasing can be also negative, -100 to -50. That is also increase. But this is negate. Yeah. So always remember, increasing, decreasing has nothing to do with positive and negative. Positive and negative will come with the help of angle only. Is it okay? Is it okay? Bolo 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 torga 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 torga. No problem, no problem, no problem, no problem, no problem. Now we will talk about one acceleration time graph, then we will start some question from here. We'll do 2-3 questions just to give you better idea. Just to give you better idea. Before that, we will talk about 1-2 acceleration time graph. You can write acceleration time graph. Acceleration time graph. Acceleration time graph. So what is slope of acceleration time graph? What is slope of acceleration time graph? Here slope was giving velocity time graph, slope is acceleration. What is slope of acceleration time graph? What is slope of acceleration time graph? Bolo jaldi. What is slope of acceleration time graph? What is slope of acceleration time graph? I am waiting for your answer, Baba. Nothing. Slope of acceleration time graph is nothing. That is area, Baba. Change in velocity is the area. Slope of acceleration time graph has no significance in physics. Area has significance. Area will have significance, that we will talk. That we will talk. Yeah. So always remember here slope. Now slope will not give you anything. What happened just here? What I'm trying to tell. For displacement time graph, I was always talking about slope, slope, slope. For velocity time graph also I'm talking about slope, slope. But for acceleration time graph, I will not talk about slope. Dhyan do what I'm trying to tell. For velocity time graph, for displacement time graph, I was saying slope increasing, slope decreasing. For velocity time graph also I'm talking about slope, slope, slope. But for acceleration time graph, I will not talk about slope because slope has no significance there. So slope of acceleration time graph will not give us anything. Then how to tackle question of acceleration time graph? Dhyan dena, just see here ek baar dekh lo. Once Valagandi will happen, you'll never feel any problem. Dhyan dena, just see here. Yeah. So anyone ask me about acceleration time graph? So just see here acceleration time graph. Acceleration time graph. Now here what happened, they will give you one acceleration time graph and they will ask you to convert this acceleration time graph into velocity time graph. They will ask you to convert this acceleration time graph into velocity time graph. This is our velocity time graph. They will not ask you what is slope, nothing they will ask you. They will give you an acceleration time graph and they will ask you draw its corresponding velocity time graph. Can you think? Now you will simply say, now don't look at the slope. Slope 0 has no importance. Now you look at the acceleration itself. You will say here, sir, here acceleration is constant. And that constant acceleration is above x-axis. That means that constant acceleration is positive. This constant acceleration is positive, sir. If constant acceleration is positive, your velocity will increase. So this is corresponding velocity time graph. If your velocity time graph is like this is its acceleration time graph. If acceleration time graph is like this is its velocity time graph. Is it okay? Are you getting idea? Arey bol do ek baar. Acceleration. So here slope you don't have to see. You will simply see acceleration. So acceleration is constant na, constant positive na. That means acceleration is constant positive. What will happen to velocity? Velocity will increase with constant slope. Velocity will increase with constant slope. That is what you are finding there. That is its corresponding velocity time graph. Can you draw its corresponding displacement time graph? Can you draw its corresponding displacement time graph? Remember last lectures we studied situations where acceleration was positive. You had displacement time graph. Batao, you can tell me about the slope. Now velocity is increasing now, means slope of displacement time graph must be increasing. If velocity is increasing, this here acceleration constant now, so velocity time graph slope must be constant, and here velocity is increasing now, so here slope of displacement time graph must increase. Are you getting the idea how to convert one graph into another graph? Fourth graph will come. Yeah, fourth graph will come. I will mix all of them after some time. Yeah, okay, no problem, no problem. कुछ चमका क्या? From acceleration time graph, see the value of acceleration. Sir, acceleration constant positive. That means sir, velocity of the particle will increase. If acceleration is constant, velocity will increase with constant slope. If velocity will increase with constant slope, I know sir, if velocity will increase, slope of displacement time graph must also increase. That is the graph. If you understood this, tell me about this. Come on, tell me about the second one. Only two graphs are there. Tell me about the second one. If I have acceleration time graph, but now acceleration is given negative. This is our acceleration. Acceleration is given some negative value below origin. Tell me what will be its velocity time graph. Particle has some initial velocity. Now you will simply say, sir, here acceleration is, now don't see about its slope has zero importance. So acceleration is here constant, sir, but constant acceleration is negative. And you know when constant acceleration is negative, that means velocity will decrease with constant slope, because slope of velocity time graph is acceleration. So velocity will be, sir, acceleration is negative. That means slope of velocity time graph must be negative and constant negative. Constant negative means velocity has to decrease. This is the corresponding velocity time graph. And in displacement, fifth graph will come. Very good, Jyoti. Yeah, in displacement, fifth graph. Now your velocity is decreasing na, Baba. Velocity is decreasing na. Dekho yahan pe, velocity is decreasing. Your displacement time graph will be. If velocity is decreasing, slope of displacement graph has to decrease. Means decreasing slope. Fifth graph will come. Very good, very good, very good. No problem. You can write all these things. I'll give you one question. I'll give you one question. You write, chalo. Now I'll give you one question in the form of language. Then you have to draw all the three graphs. You have to draw all the three graphs. Not a tough situation, but this question will give you little more idea. Your brain will open once we will talk about this question. You write this question. Chalo, ek baar likho is question ko. Come on. You write. You write. A particle starts from rest. A particle starts from rest with constant acceleration. A particle starts from rest with constant acceleration, and a particle starts from rest with constant acceleration and moves for some time. A particle starts from rest with constant acceleration and moves for some time. Then after attaining maximum velocity, it moves with constant velocity. Then after attaining maximum velocity, it moves with constant velocity for some time. And then finally retards, to come to rest. And then finally retards to come to rest. And then finally retards to come to rest. Means first accelerated motion, then constant velocity, then retarded motion, and then finally retards to come to rest. Draw its. First you have to draw its velocity time graph. Then you have to draw its acceleration time graph, and then you have to draw its displacement time graph. Three graphs you have to draw for this particle. All the three graphs which are possible, we are talking about them. I think it's very tough for you to say because you cannot show your copy. But read the question, that will give you idea. I'll put displacement time graph here. Third one is our displacement. This question is just to develop your understanding. All the three graphs, if you are able to do, you got the idea how to do all of them. Always remember, out of three graphs, most easy graph is the velocity, because we always have more feeling with the velocity. Whenever you drive scooty, you always talk about my velocity is less, velocity is more. So whenever such graph is asked, first draw velocity graph. Okay, Surya is saying something, no problem, no problem, no problem. Yeah, okay. So come on, no problem, yeah. After this, I will give you some more graphical question. There I will give you option also, so that you can say. So I think this is its velocity time graph. Just see here. Okay, no problem. Sir, what they're saying you? Yeah, okay, no problem. What they're saying you, a particle starts from rest with constant acceleration. Means velocity will increase with constant slope. Constant acceleration is what, Baba? Acceleration is the slope of velocity time graph. So I simply say, sir, velocity is increasing because particle has acceleration. So velocity will increase, but with constant slope. So first, for some time it is accelerated, velocity will increase with constant slope. Then velocity is constant, means now they are saying velocity constant means acceleration will become zero. Acceleration zero means slope of velocity time graph will become zero. That means your velocity will become constant. After that it is retarding. Velocity will decrease and it will come to zero. Is it okay? बोल दो एक बार, is it okay? Velocity time graph okay? Velocity time graph okay? Velocity easy na baba. Starting from rest, velocity will increase. Velocity increased, then maximum velocity came. After that it is moving with constant velocity. After that it is retarding, so velocity will decrease. Okay, no problem. Now once you have drawn velocity time graph, acceleration time graph you can draw. You will simply say acceleration time graph, sir. First particle has positive acceleration. Particle accelerate with constant acceleration. So first constant acceleration. Tarvata. For some time, constant velocity means acceleration will be zero. Then particle is retarding. Retarding means acceleration will be negative. Is it okay? Dekh lo acceleration time graph. In the beginning, you have constant positive acceleration. Tarvata, constant velocity means zero acceleration. Tarvata, retardation means negative acceleration. Is it okay? Acceleration time graph. Acceleration time graph. Bolo. So displacement time graph you can draw. I will give you option for the displacement time graph. For displacement time graph, I will give you option. First option, second option, third option, fourth option. Which is the option? Come on, for displacement time graph, which is the option? First, second, third, fourth. Second one, Janvi very good, Sajid very good, Bodhbar, Lachna very good, Chintu very good, Ems Delhi very good, Kushba very good. Second is the graph. Because initially velocity is increasing, means slope of displacement time graph must increase. What is velocity, Baba? When I talk about displacement time graph, velocity is the slope na. So initially body has acceleration na, means velocity is increasing na. If velocity is increasing, slope will increase. Dekho, increasing slope. Tarvata velocity constant, slope will be constant. Tarvata sir, velocity decreasing, slope will be decreasing. So our correct answer will be second one. Is it okay? Everyone got the idea? बोलो एक और क्वेश्चन दूंगा जल्दी त्वरगा. Everyone got the idea? चलो बहुत बढ़िया बहुत बढ़िया बहुत बढ़िया बहुत बढ़िया बहुत बढ़िया. हाँ, this is the way. Always remember, no one will ask you to draw the graph. Whenever you have to select out of 4, you have to select the best option. For that, quantity will help you, slope will help you, with a velocity increasing. All this data you have to use at once. I will give you one last question from here. Come on. I will give you option. I am giving you acceleration time graph. First acceleration positive, then acceleration 0, then again acceleration positive. This is acceleration time graph. No problem, no problem, no problem. You have to tell me its corresponding velocity time graph. Velocity time graph, first velocity time graph, second velocity time graph, third velocity time graph, fourth velocity time, all these are velocity time graph. Fourth velocity time graph. Batao which one is the answer? Which is the correct velocity time graph for this given acceleration time graph? सोच के बताना. Kushma very good, Janvi very good, Farida very good, Emsali very good, Sajid, yeah, you understood how to deal with the graph. Come on, yeah, done. Graph అయిపోయింది. You have got the idea. You have got the idea how to tackle the graph. That is the main thing. That is the main thing. Sir, acceleration positive means velocity will increase at constant rate. Constant rate, velocity will increase with constant rate, with constant slope. Increase. Tarvata acceleration 0, velocity will be constant. Again acceleration positive, again velocity will increase. This is the graph. Third graph will be our answer. Previous graph, this was negative, that's why velocity was decreasing. Now in here, this is still positive, that's why velocity will again increase. Bolo, 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 Twarga. Everyone got the idea? I think you are getting the idea, no problem. जल्दी बोलो भाई. हाँ, no problem, no problem, no problem, no problem. Yeah, okay, no problem. हाँ. Acha, one more thing, one last thing I will talk. 1-2 more things we will talk here, then we will finish out our graph part. Just see here, okay. Area part also we will see. Don't worry about that. Just see here. Yeah, okay, no problem, no problem, no problem. Yeah, okay. Acha. Sometimes some special graphs are asked. Dhyan dena. For example, just here, no problem, no problem. For example, some graphs are asked like this. Just see. Okay. They will say, right now I have told you displacement time graph. I told you velocity time graph. I told you acceleration time graph. But sometimes in question, what happened now? They ask velocity and displacement graph. They will say velocity. So always remember, whenever, dhyan do what I'm trying to tell. Whenever, apart from displacement time graph, velocity time graph, acceleration time graph, if any other graph is asked, first relate those two quantities. For example, just see here. For example, I will give you one question. Come on. You write. A particle starts from rest with constant acceleration. Jaldi, a particle starts from rest with constant acceleration. Draw graph between its velocity and displacement. Draw graph between its velocity and displacement. Assume initial velocity to be 0. A particle, or you can say, starts from rest in the beginning only. Yeah. A particle starts from rest with constant acceleration. Draw the graph between its velocity and displacement. Now this question came out of our syllabus. Sir, ये तो पढ़ा ही नहीं. Sir, you told displacement time graph, you told velocity time graph, you told acceleration time graph. Now you are asking graph between V and S. So क्या करे sir? I will give you option. Option also you can take, no problem. This graph will be like this. Second option, graph will be like this. Third option, graph will be like this. Fourth option, graph will be like this. VS graph. Such questions are not generally asked. Kusma is saying, yeah, such question is there in the gym also. This is question just to trap you. Jyoti is saying some answer. But my looking at my expression, Jyoti knows her answer is wrong. Yeah. Ames Delhi is saying correct. That is also wrong. Ames Delhi, that is also wrong. Janvi also wrong. Dhyan do, dhyan do, dhyan do, dhyan do, dhyan do. There is no benefit of using the knife in darkness. Dhyan do. Point is, थोड़ा एक बार focus करो. थोड़ा एक बार focus करो. Understand what I am trying to tell. What I am trying to tell. Till now I have given you at least 20 graph now. All the time all of you are giving correct answer. All of you giving correct answer because generally we talk about displacement time graph, velocity time graph, acceleration time graph. But here it came neither velocity time graph, nor acceleration time graph, nor displacement time graph. तो क्या करे सर, कैसे ग्राफ बनाए? Don't give answer, listen. So always remember, apart from these three types of graph which we have done, if any other graph comes, first try to relate the quantities. Relate karo. V given, S given, can I relate them? Yes. Third equation of motion. That's why they have said acceleration is constant. Relate V and S first. Sir, I know V square minus U square equal to 2AS. They have said U0. If U is 0, now someone is saying, yeah, La Krishna correct, second option will come. Now from here I will say U is 0. That means V square equal to 2AS. That means from here I can say V square proportional to, remaining things are constant, V square proportional to S. Means V will be proportional to root S. Now V is present on which axis? Y. And S is present on X axis. So Y proportional to root X. And I think everyone knows graph of Y equal to X square and graph of Y equal to root X. Root X graph comes like this. If you have studied in graph, I think you have studied, yeah. Root X. If you have not studied, no problem. Learn here. Root X graph comes like this. This is the graph for Y equal to X square, and this is the graph for Y equal. This is the graph for Y equal to root X. This is the graph. Here also you are getting now V proportional to root S. Now check karo kaun sa. Now check karo kaun sa. Now check karo which graph will come. Second option will come. If you don't know this, now know it. X square graph and root X graph. Root X graph will come here. Is it okay? Is it okay? हाँ, second option will come. Now I think you got idea. कुछ समझे क्या? Did you understand what I wanted to tell? This question is not important. Important is yeah. So always remember, whenever any other graph comes now, you have to first write relation between those two quantities. Previously, you are already knowing the relation between displacement time graph and velocity. That's why you are able to do directly. But here you will not be able to do directly. Yeah. Okay. So that's how we can talk about. So first you have to get the relation between V and S. V proportional to root S came. Now V proportional to root S came is V proportional to root X. V is on Y axis. So here Y. S is on X axis. So root X. This is the graph of root X. And for root X, this is the graph. For X square, this is the graph. Is it okay? Is it okay? Is it okay? बोलो एक बार, बोल दो एक बार. The last graph I will tell you. बोलो 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 बोलो. त्वरा. Okay. Okay, no problem. Okay. This is also there in the gym. Yeah, this question is there in the gym. Yeah, okay, because important stuff, that's why I'm also talking in the class. That's why I put in the gym also. Now, some graphs are asked. Dhyan dena. Some situations which will help you tomorrow. Some situations I will tell you in 5 minutes. Then we will finish out our graph. Yeah, okay, just see here. Some graphs are asked, ध्यान देना, be focused. Some graphs are asked related with motion under gravity. Some graphs are asked related with motion under gravity. ध्यान देना, how to tackle them. Again, wherever graph is asked related with motion under gravity now, again you have to write equation of motion first. Because there they will ask you about particular velocity, particular acceleration. You have to write equation of motion. You have to write equation for their motion. Then only you can get to the answer. For example, I will give you one question. Come on, you write. A ball is dropped from certain height. A ball is dropped from certain height. A ball is dropped from certain height. Draw its velocity time graph. Draw its velocity time graph. A ball is dropped from certain height. Draw its velocity time graph. Draw its velocity time graph. So this velocity time graph will be having which nature? It will be a straight line or which nature? It will be a straight line or which nature? What will be its nature? Constant acceleration. Velocity will increase now. Straight line, because directly proportional. Your V and T will be directly. This is what I was trying to tell there. I will simply say dekh lo ek bar dekh lo, ek bar dekh lo, ek bar dekh lo. Ek bar dekh lo, how we will be talking. Ek bar dekh lo, just see here. Yeah, okay, no problem. I will simply say, sir, you are dropping the ball. You want relation between velocity time graph. This is a particular situation now. So first you have to write. You know when you drop the ball, V will be equal to U plus AT. You know you are dropping the ball. So U will be 0. A will be G plus G, because ball is going down, gravity down. Yeah, ball is going down, gravity down. That means V will be equal to GT. That means now you have to plot this graph. This is same as y equal to mx. This is same as y equal to mx, or you can say v directly proportional to t. Directly proportional means we will get a straight line like this. Slope of this straight line, if anyone asks you tan theta, this tan theta will be equal to a, which is here g. Is it okay? Bolo. एक बार बोल दो. कुछ समझे क्या? Last question, chalo. One question is there in the gym. Same question I will give you so that you will not feel problem there. Yeah, one last question. So this is the way. Always there is no hard and fast rule to tackle with this type of graph. You have to write the equation. You have to think. You have to see where velocity is 0, where velocity is maximum. All these things you have to see, and accordingly you have to plot the graph. Last question, चलो एक और question बनाता हूँ. चलो, you write. A ball is thrown vertically upward. Last question. A ball is thrown vertically upward. A ball is thrown vertically upward. A ball is thrown vertically upward. With speed u. And it comes back to the ground with the same speed u. Of course, if you throw the ball with speed u, ball will go to maximum height. From there it will come back with the same speed u. Which of the following is its velocity time graph? You have to tell me which is its possible velocity time graph. Which is its possible velocity time graph? What is its possible velocity time graph? possible velocity time graph. Which one is its possible velocity time graph? एक बार जल्दी से बता दो भाई. You're not using brain. You're using everything but brain you are not using. As तो ध्यान दो. You are throwing the ball vertically up now. Manish Chala correct, Lachna correct, Surya third option is the correct answer. थोड़ा दिमाग use करो. Everywhere slope will not help you. These are practical graph. Here your understanding of physics will help you. ध्यान दो ध्यान दो ध्यान दो. Just see here, just see here, just see here. Yeah. Okay, no problem. एक बार देखो, एक बार देखो. Correct answer is the third graph. Now here slope and everything will not work. Your basic understand. You tell me when you throw. ध्यान दो. You tell me when you throw the ball vertically up. When you throw the ball vertically up, what will happen to the velocity? And when you throw the ball vertically up, ball will have some initial velocity now. You tell me as the ball will go height, what will happen to velocity? As the ball will go up, what will happen to its velocity? Jaldi batao. Velocity will decrease now. Velocity will decrease now. At maximum height, what will happen to velocity? At maximum height, what will happen to velocity? First, practically, you have to imagine the situation. At maximum height, velocity will become 0. After that, what will happen? 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 Velocity will again increase in downward direction. Again, ध्यान दो. When you are throwing the ball vertically upward, as the ball will go up, velocity will decrease. At the maximum height, velocity will become 0. Tarvata, in opposite direction, velocity will increase. And when it will come to your hand, it will come with the sun. That is what you have to see in the graph. See in the first graph, they are saying velocity is increasing. You tell me when you throw the ball vertically up, does velocity increases? When you throw the ball vertically up, does velocity increases? No. Wrong graph. Sir, second situation, they are saying velocity. I am throwing the ball vertically up. They are saying velocity is constant. Velocity is constant. Is velocity will be constant? No. So when you throw the ball vertically up, what will happen? As the ball will go up, velocity decreases. At maximum height, 0. After that, again it falls down, increases, but it increases in reverse direction. That is what happening in, you see, when you are throwing, this is t equal to 0. As you are throwing velocities, what is happening to velocity? Velocity decreasing. This is your H max. When velocity became 0. Tarvata, velocities again started increasing, but started increasing in opposite direction. कुछ समझे क्या? This graph has no meaning. बोलो. Point is, there is no any rule to say this thing. That's why you have to think about the situation. थोड़ा सोचना पड़ेगा, दिमाग लगाना पड़ेगा. Now nothing will work. So your brain has to. That's why I was saying you. Every graph you have to look and you have to think what is given, what is asked. Then only you'll get the answer. Is it okay? बोल दो एक बार. So this type of graphs are asked, which you can do very easily. Nothing to worry. Generally they don't ask. If they ask you, these are only the graph which we have already done. I'm giving you time of 5 seconds. एक बार देखो. We'll move further. आगे बढ़ेंगे. चलो. बहुत बढ़िया. Once completed, you can say done, sir. Now after class, do all the question of graph from the gym. I know once I will say done, sir, you start saying done, sir. Okay, no problem. Now, 1-2 things I will tell you related with area. ध्यान देना, be focused. You tell me what is area of velocity time graph? What is area of velocity time graph? What is area of velocity time graph? जल्दी बताओ. What is area of velocity time graph? What is area of velocity time graph? जल्दी त्वरगा, time ले दो. डिस्प्लेसमेंट 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 डिस्प्लेसमेंट। ध्यान दो यहां पे ध्यान दो। न्यूमेरिकल आई विल नॉट गिव यू, थोड़ा ध्यान देना। पुट योर ब्रेन देयर व्हाट आई एम ट्राइंग टू टेल। ऑलवेज रिमेंबर, sometimes what happen, I'm talking about some situation related with area, some conceptual point I'm going to talk. What happens here, for example, they will give you velocity time graph like this. Assume I'm having velocity time graph, sir. I am having velocity time graph like this. This is my velocity time graph. This is my velocity time graph, sir. No problem. Now ध्यान देना. Someone gave me velocity time graph and he asked me, sir, find displacement. I already know, sir, you want displacement now. Displacement is area of velocity time graph. Area of velocity time graph. Now what is area? Now always remember, here two area may come. One area is above x-axis now. For example, this area I am naming as A1. One area is below x-axis now. So always remember, the area which comes below x-axis, that area will be treated as negative. ध्यान दो, whenever you are calculating displacement means a vector quantity. The area which will come above x-axis will be considered to be positive. Area below x-axis will be considered to be negative. So if anyone asks you displacement will become A1 plus of minus A2. समझे क्या? Below x-axis your area will be negative. Above x-axis positive. Yeah, Durga Prasad, that is trapezium. You can calculate. You know how to calculate that area. No problem. Yeah, everyone got my point. I wanted to correct one point with you. Two areas are possible now. Paina okati, kenda okati. So for displacement, paina positive, kenda will be negative. Is it okay? Bol do. But in the same question, someone asks you, sir, I don't want displacement. I want distance. Tell me directly distance. Why you are talking about displacement? Tell me distance. Always remember, distance cannot be negative. So for distance, all the areas will be positive. For distance cannot be negative. So this is also some distance, but this is negative. That's why for displacement we have taken it negative. But for distance, it will come A1 plus A2. All areas will be positive. All area is positive. Whether it is below x-axis, above x-axis, doesn't matter. Are you getting the idea? Our displacement is a vector now. For displacement, above will be positive and down will be negative. For distance, above also positive, down also positive, doesn't matter, because you know distance cannot be negative. Is it okay? Bolo ek baar. So if anyone asks you distance, find above area, below area, then below area will be negative. But for displacement, below area will be negative. For distance, all area will be positive. एक बार बोल दो, come on. हाँ? नहीं समझे. Okay, no problem. Yeah. For distance, all area will be positive. For displacement, above x-axis positive, below x-axis will be negative, because displacement is vector na. Direction also matters. So that's why we'll be getting like that. No problem. I'll give you a last question from here. Chalo, jaldi se bana do, jaldi se. Come on. Do one question. Achha, what is area of acceleration time graph? What is area of acceleration time graph? Change in velocity. Change in velocity means not velocity, Baba. Change in velocity. I will give you one question. You write. Find the maximum velocity of the particle. This is a famous question in acceleration time graph. Find the maximum velocity of the particle. Find maximum velocity of particle if it starts from rest. Find the maximum velocity of the particle if it starts from rest. Find the maximum velocity of the particle if it starts from rest. Janvi correct, Syam correct, Durga correct. I'll simply say, sir, you have given me acceleration time graph. Acceleration time graph. I know, sir, you have given me acceleration time graph. You are talking about velocity. I know. Area of acceleration time graph is change in velocity. Now area you can find. This is the total area, because you want maximum velocity. That means you have to take the total area. Maximum area you have to take. So maximum area will be the total area. That will be half into base 10 into height 10. This will be equal to delta V. Delta V means V minus U. U is 0. So from here it will be coming as, V will be coming as 50 meter per second. At this velocity will be also your maximum velocity. Is it okay? Is it okay? Bolo, 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 bolo. Torga. Eh? Bolo, bolo. Achha, why area will be, why velocity will be maximum here? I have taken mottam area now. Why I have taken velocity to be maximum at 10 seconds? Why not after that? Because after that your area will become negative. Why we are stopping? For example, tomorrow this graph goes up to like this now, and someone asks you find maximum velocity. Again you have to consider area only up to this. Because after this area will become negative. Net area will start decreasing. You want maximum velocity, so you have to take area maximum. Maximum area means maximum above x-axis you have to take. Because below x-axis, that area will become negative. Are you getting my point? Why we are saying, sir, velocity will become maximum at t equal to 10 seconds. 10 second tarvata acceleration is becoming negative na baba. If acceleration is becoming negative, velocity will decrease na baba. So up to 10 second acceleration was positive, velocity was increasing. So that's why up to 10 second you will get maximum velocity. Is it okay? After 10 second acceleration will become negative na. Negative acceleration means velocity will decrease na. अरे कुछ समझ में आ रहा है? No problem. And one last thing I will tell you. Just see here. Okay, no problem. So we have completed our graph. Next class we'll start with projectile. Acha, you tell me, is this graph is possible? Displacement time graph. Is this displacement time graph is possible? This displacement time graph is possible? Vijay is saying no. Why? Always remember, some questions are asked which graph is impossible. Always remember, a graph becomes impossible only when at the same time two positions are there. At the same time you cannot have two position, two velocity. Here if you check this time your displacement is this also. Your displacement is this also. That means this graph is impossible. NCERT has given exemplar, has given some question. That's why I'm talking about this. For example, someone came and he gave you velocity time graph like this. Is this velocity time graph possible? Possibility है क्या? नहीं है भाई. At the same time, here if time is 2 seconds, at the 2 second your velocity is this also, your velocity is this also, your velocity is this also. How it is possible? At the same time, how anyone can have 2-3 velocities? Impossible. Okati time low, okate velocity. Okate time low, okate position. Okate time low, okate displacement. Always remember, at one instant, we can have one position and only one velocity. One position and only one position and only one velocity. If two velocities are there at the same time, it's impossible. Is it okay? Samjhe kya? Easy part, but I did it. No problem. So this is how we have talked about. I got very late. More situations from here we'll be talking in the next class. For today we'll be ending class here only. Tata, bye bye, study well. Bye 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 bye.